A really warm welcome to this maths event, though, and I'm delighted to say I'm joined today by Dr Paul Griffiths, who's joining us from Coventry University, and Dr James Groves, who's joining us from Lancaster University, to offer two presentations on studying maths at university. Paul will present first, and then pass on to James after we finish, and I'll be hosting the event throughout and also looking after the Q&A and getting answers to any Q&A questions you post if you're watching this as a live event. But without further ado, if I can introduce Paul, please. Paul Griffiths is an Associate Head of School at Coventry University, and Paul's going to do a session now on introducing university courses in maths. Over to you, please, Paul.
So I'm going to give you guys just a little bit of an introduction about what I think studying mathematics at university looks like. Okay. So today's outline. So some questions I'm hoping to answer for you guys today. So what does studying mathematics at university look like? So what can you expect? Why would you want to study it? Okay, and what prospects do mathematicians have? So what prospects would you guys have after you finish a mathematics degree? So I work as an assistant professor in applied maths at Coventry University. So I spend my time doing lots of different things. So I teach a variety of courses, so university level maths courses. I also deliver some courses to our engineers. I conduct research in applied mathematics, and I'll talk a little bit more about that in a second. And I like to do these types of events where we do promoting for things to do with science, technology, engineering, and mathematics, all those good types of things. Okay, so a little bit about what I do, just to give you guys some background, and then we'll talk a little bit about what you guys can expect at university. So my research, so as I said, I'm an applied mathematician, okay, and I look at solving interesting applied maths problems. So on the screen at the moment, we've got a picture of an aircraft with some vortices appearing at the back of it, and we've got a picture of some ketchup. So these two things don't traditionally link. Okay, the link may not be obvious to you at the moment, but what I do, the sort of research I look at, is combining these two types of things. Okay, so everyone, or the vast majority of people, have had an opportunity to be on a plane. Okay, and you're told, you need to sit down. There's some turbulent flow. Can you please put your seatbelt on? And it's annoying for us because we're in the aeroplane and we want to get up and walk around, but it's equally as annoying, or more annoying, for airline companies because it costs them a lot of money. Okay, if we could solve or resolve the problem of turbulent flow, if we could eliminate it, then that would be hugely beneficial. And I look at these types of problems where we're looking at weird and wonderful types of fluids, what are called non-Newtonian fluids. An example of that might be ketchup or custard, or these types of things. So it's just an example of how you can use what we call applied mathematics in the real world. So alongside my teaching, I spend some of my days thinking about these weird and wonderful problems. So what can you guys expect if you're going to study mathematics at university? So I'm going to give a fairly kind of broad overview. I won't be specific to the university I'm at. Some of the information will be kind of general across most universities in the UK. Some things might be a little bit more specific depending on where you study, but it's just to kind of give you guys kind of a generic overview. Okay. So generally, if you go on to study mathematics at university, you would expect to learn about pure mathematics, applied mathematics, and statistics and probability. And more than likely, you've seen all of these things in some capacity before. So I'm going to work with the assumption that the majority of the people who are interacting with today's webinar are doing A-level mathematics or some course similar to that. So pure mathematics, you could think of as, I think, what they're traditionally termed the modules C1 to C4. Applied mathematics, that could be like your mechanics module, so M1, and statistics, okay, that could be like your S1. So when we move on to the university level, we kind of continue with those sorts of themes and look at them in a bit more detail. So pure mathematics will be solving kind of more abstract type problems. Applied mathematics, which is the thing I'm really interested in, so finding solutions to real world problems, as I just talked about, and statistics, so analyzing data and predicting future outcomes. And this is becoming more and more of an area for growth. And you'll probably have already noticed that there's lots of courses offering, mathematics and statistics, or maybe even a data science course. So the basis of data science really is mathematics. So there is a much larger focus now on these types of courses. So it won't just be maths that you're studying. I can guarantee you that no matter where you study. You'll also develop lots of other skills. So in terms of computer programming, presentation skills, group working skills, all these important types of things. So I've given a very generalized overview of a mathematics degree. Okay? And as I said, this would change obviously from university to university. And I would suggest that, you know, if you have a particular university in mind, you go to their webpage and more than likely they'll have information about the modules that they're running. But generally in the first year, you can expect to kind of continue what you've been studying already. So developing these ideas of algebra and calculus. So if we're talking about A-level, I think those are C1 to C4. Okay? So you're going to build on those things. You're going to recap what you've done before and do considerably more in the first year. Okay? You'll then probably have some sort of introductory course on numerical methods. Okay? So this is where I was talking a minute ago about, you know, developing skills in computer programming. More than likely, you'll also look at things to do with statistics and probability, and then mechanics and modeling. So I would say that, you know, the vast majority of undergraduate mathematics courses in the UK would have this kind of structure for their first year. And it'd be interesting actually to hear James's opinion in a minute to see if they do things very similarly at the university that he works at. So the second year, you'll continue kind of on this theme of developing techniques in algebra and calculus and numerical methods, because these are the tools that we need to develop in order to solve problems. By the time you get to the second year, it's more than likely you'll have optional modules to choose from. So as you develop throughout the course of your degree, you'll find that, you know, you really enjoy the modules to do with pure mathematics or applied mathematics or statistics, and you'll be able to follow that path and choose modules which are most interesting for you. By the time you come to your third year, I'd say that it will largely all be optional modules, plus some sort of project, more than likely. That might be in the form of a dissertation, a small research project, these types of things. So you're kind of developing as an independent learner, as an independent mathematician, as you move through your degree course. I've got a little bit of information there at the bottom about how you know, the course would be delivered. Again, it would change from place to place, but I mean, you would always expect to have large lectures, small group workshops, tutorials, and computer lab sessions. I always get lots of questions about how will I be assessed. So I just put something in there at the bottom. You know, the majority of modules, at least at the universities I've worked at, you have assessments via coursework. So that might be individual coursework or group work, and probably some form of an examination at the end as well. Okay, so that was a very quick whistle-stop tour of what you might expect when we go to university. So talk a little bit now about motivation. So why would we want to study mathematics? You'll notice that there's an orange bar kind of running halfway along the screen. So that tells us how long through the presentation we are. Okay, so we're about halfway there already. So hopefully you're not falling asleep just yet. So I'm going to talk a little bit about some information from the Institute of Fiscal Studies. Okay, so you may have heard of the Institute of Fiscal Studies before. So they're a research institute that do lots of things for the government and help develop public policies and these types of things. So they had a report out a few years ago, earlier this year in fact, on the impact of undergraduate degrees on lifetime earnings. So I just have one slide here about, you know, what you might expect as you graduate from a mathematics undergraduate degree course. So this plot just shows real earnings by degree subject studied at the age of 29. Okay? So we can see a range of different undergraduate topics there, and we're interested on the right-hand side, which is at the upper end, or I'm sure that you guys are. We'll notice that economics at the top, then perhaps unsurprisingly medicine, then after that is mathematics. Okay? So on average, according to this study from the Institute of Fiscal Studies, which was quite a wide-ranging study, students from mathematics undergraduate courses, by the time they turn 29, would expect to be earning in the region of, on average, £40,000 a year, which I think is not necessarily a bad thing. Not that the volume that you earn each year is the true indicator of how much you're enjoying your work. I'll talk a little bit more about that in a moment, but perhaps that's kind of reassuring to know that, you know, a mathematics degree certainly is worthwhile in terms of future job prospects. So, talking about prospects, so what sort of prospects do mathematicians have? So I'll talk quite briefly, I think, about this. So here's just a list of, or a kind of screenshot of a range of different employers. And these are some employers that students from the university that I work at have been to on placement in the last few years. Okay, so there's a huge range of different companies on here. Some of which you might expect students from a mathematics background to go and do an industry placement with. So we have kind of engineering type companies here. So, you know, Rolls-Royce, these types of people, Apple, okay, so Santander, you know, banking groups, PwC, you would probably expect to see these types of companies here. Perhaps you wouldn't necessarily expect to see, you know, the BBC or Warner Brothers. I'd say the one thing that all these companies have in common is that they deal with, you know, huge amounts of data, and they need people who can solve problems. Now, mathematicians are basically problem solvers. Those are the skills that you're really developing during the course of your degree. So those skills are very highly employable. I think this is evidenced by kind of the wide range of companies that are interested in mathematics undergraduate students. So as I was saying, you know, mathematicians exist to solve problems, and throughout the course of your degree, you'll be developing these problem-solving skills, and this is what employers want to see. So more than likely, that your undergraduate degree course will offer the option to go on some sort of an industrial placement. And I always recommend this option to my students. I think it's a fantastic option. I mean, it gives you an opportunity to apply what you've learned throughout the course of your degree, you know, into a real world situation. You get paid for it, which is great. You come back to university to complete your final year of study. More often than not, you're really motivated, because either you know exactly what type of job it is that you want to do because you spent time doing it, or you know exactly what type of job you don't want to do because you've spent a year doing it. Okay, so you've got the motivation to continue on, complete your degree, and go on the path that's right for you. So I think I will end, and I may be a little bit quick, but talking about the path that's right for you. I always have this slide at the end of this type of talks, just because I think it's really, really useful. So talking about how I got to where I am. So you guys are more than likely already doing your A-levels. I chose my A-level based purely on the subjects that I enjoyed, and I hope that you guys did the same thing. I decided to go to university to continue studying things that I found interesting. So I actually did a degree in mathematics and engineering at the same time because I couldn't choose. During the course of my undergraduate studies, I had a chance to do a research project, which I thought was really, really interesting, and then had the opportunity to stay on and do a PhD. Basically, the theme that's running through here is picking out things that you enjoy and that you find interesting. Okay, so I'm not here to preach to say, you know, you have to go to university to study mathematics, and that's not the reason why I'm here today. What I'm here to do is to provide you guys with some more information, but I'd just like to give that with a caveat that, you know, make sure you're enjoying what you're doing, because if you're enjoying it and it's interesting, it won't seem difficult. And if that's the case, you know, then you will succeed. So hopefully that was useful. I think we may have had some questions come in on the Q&A, which is good. So I think I'll stop there. I'll hand back to John, and I think we'll hear a little bit from James as well. So if I stop sharing.
Thank you, Paul. Excellent session. You've left us all wondering why tomato ketchup is so hard to pour now. You said that, though. But really, really good introductory session, looking at lots of different subjects in maths as well. So I really appreciate that. Thank you. Paul did mention about the Q&A, and actually a question just coming straight away. There has been some questions already, and Paul is kindly agreed to be on hand now for the next 20 minutes, so 15, 20 minutes, to answer some more Q&A questions. So thanks very much, Paul. Really, really appreciate that. If I could now introduce our second speaker, please. That's Dr. James Groves, who's joining us from Lancaster University. James is also a member of academic staff in the maths department. So he's going to talk about several of the things that Paul's probably talked about as well, but offer a different perspective on it. I know James is going to include the type of things you're going to study. He might even include some tips as far as picking qualifications for students that haven't yet picked option choices, etc. But you've not tuned in to hear from me, you've tuned in to hear from James and Paul. So I'll stop talking and pass the floor, please, to Dr. James Groves, joining us from Lancaster University. James is a senior teaching associate over there. James, the floor is yours, please.
Hello. I'm hoping you can see me. So yes, thanks, John, for inviting me, and I'll try and speak for, again, something like 10-15 minutes. Perhaps I should start by giving a little bit about my background. So very, very long time ago, I was picking my A-levels, and I did maths, physics and chemistry. And I went from that to Cambridge to do maths. Why did I pick maths? Because I enjoyed it, basically. I think that was, at the time, that was pretty much my overriding decision. And I think maybe I had a feeling for it could be useful, but it was mostly simply enjoyment of the subject, and the career opportunities were perhaps a bonus. And then from there I went to do my PhD at Lancaster a very long time ago, and barring a couple of years off, I've mostly been there ever since. So I'll be talking basically about maths in general. I'll occasionally mention things at Lancaster, but I'm hopefully fairly impartial. So if you have any questions about how places differ, I'll try and give as impartial an answer as possible. And now I'm going to try and share my screen. So hopefully in a second, you will see a presentation, and I've asked John to shout at me if anything goes wrong. So people often ask what do mathematicians do, and what can you do with a degree in maths? And surely mathematical problems were mostly solved around about the time of Newton. So is there anything more to study rather than these days? And I often point out that there's more active mathematical research and investigation now than there has ever been, and not just at universities. In fact, most professional mathematicians and statisticians are doing what they do in industry or working for government. There are people who stay at university, and often they collaborate with industry and government, but it's a very, very wide-ranging field. And if you have three mathematicians in a room, the chances are they have three incredibly different roles and careers. This strange diagram that I put on the slide is an example of that. It's an illustration of a phenomenon called percolation, which you can think of it in an applied context as it's modelling, perhaps in sort of a geological context, about things, water diffusing through rock, or you can think of it maybe even from a computer science perspective, in terms of the way that some data might move through a system, or you can think of it from a pure mathematical point of view as, here are some interesting dots, and we'll join the dots in a random fashion, and we'll ask questions like, what's the probability that I can get from kind of the left-hand side to the right-hand side, without being stopped? And that's actually quite a hard question. So if I said that, there's a probability P that each line joining a dot was either closed or open, the question as to whether I can get from left to right is quite a difficult, pure mathematical problem, and we can study that from a totally abstract point of view, or we can actually, if we're working in industry or for government, we can actually, there are many situations where that sort of pure problem can be used to solve real life problems. So I thought it was quite a nice little picture. What I thought I would do first is because people, again, often ask, okay, but what am I going to be studying? What, if I sign up for a degree in maths in my first year, what sorts of things will I be looking at? So I've got 3, these are actual problems that were set to Lancaster first years in the last academic year, actually. And some of them are of a style you might be familiar with, some not. So this is perhaps the most typical. So this is an actual thing. So if you've come across integration, then you might not be able to do the problem, but hopefully you can at least understand what's going on. So we've got an integral, we've got a function 1 over 5 plus 4 cos x, and the basic problem is, well, how do you do it? And the question's even being nice to you and even telling you what substitution to use. So this is what we would call a straightforward exercise. Some people in maths wouldn't even call this a problem, because they would say a problem is a question where there's no clear initial way to start. And as you move through university, there are fewer and fewer of these, what we call routine puzzles, where essentially if you do that substitution, you get the answer out after quite a few lines. And there are more open-ended puzzles where it's often not entirely clear where you would even start. So trust me, if you've not yet come across integration by substitution, you'll probably come across that in year 13. And armed with that, this is basically an exercise. So there is some of that at university. We do want people to be able to do the basics well, if you like. But we're also interested in, here's another problem. Slightly different style, but again, this is a good example of a thing where you can certainly understand what it's on about. Consider the number 527. You might ask, well, could you write that as the sum of 2 square numbers? For example, 25, better get this one right. 25 is, of course, 3 squared plus 4 squared. So 25 can be written as the sum of 2 squares. But can 527 be written as the sum of 2 squares? Well, this question's saying, no, it can't. But it's not telling you what. It's not giving you any hints. So this is a good example of a problem where there's no immediately obvious way of, solving it. You have to think a little bit laterally as to, what properties does 527 have that maybe mean that it cannot be written as a sum of 2 squares. So this again is a thing that if you came to Lancaster, you might be looking at, maybe 3-4 weeks into your first year. But it's a problem that you can, you could explain what this problem is to somebody, in Key Stage 3 or something like that. But it does get harder. So here's my third problem. And this is an example of what I would describe as quite a difficult problem we would set our first years. And for start, we've got some notation floating around. So this is from one of our first year analysis courses. And it initially doesn't look like anything you may have seen. So we've got colour the rational numbers, whatever that means. So that means effectively the rational numbers are the fractions, half, a third, 37 over 720, that sort of thing. And we would assign each of those a number red or blue. And we want it to be in a certain way such that in between any 2 numbers, there's at least 1 red number, at least 1 blue number. And the stuff with all the symbols is that written out in formal mathematics. But what we want with this, especially at early stages, first year, is just what are your ideas? Maybe you wouldn't be maybe you'd have a go at this and you wouldn't even be able to solve it completely. We're not going to necessarily mind that. What we want to see is your ideas and if you can make any progress. And you see there's sort of extensions there as well. Well, can you do it with 3 colours? What if it's red, blue, and green? What about infinitely many colours? So can you come up with some way of assigning infinitely many colours to all the fractions, so that in between any two rationals, you can find all those infinitely many colours. So that's a good example of a what on earth sort of problem, where if you've not come across this before, you may think, whoa, what am I going to do there? But trust me to say that people generally quite enjoy these sorts of problems, because after all, you do mathematics because you enjoy it, we hope. And the idea of tackling this, we'd get you to tackle this in a small group, by the way. We wouldn't generally, we try and encourage some of the more difficult stuff for you to work in maybe groups of 3 or 4 and try and, exchange ideas and try and come up with a strategy. So those 3 sort of things are perhaps a good example of the sorts of different types of pure maths problem you might get at university. And hopefully they've stimulated you a bit. So why should you do it? Well, the main thing is, do you enjoy maths? Are you reasonably good at it? Now, what that means, I guess different people have different interpretations, but if you got a chance of getting an A at A-level maths, maybe a good B, then I would certainly say to think about a degree in mathematics. Or maybe a degree in maths with statistics. So statistics is often, because it's generally seen as a sort of branch of maths, it's often seen combined with mathematics. So if you like maths but also like statistics and want a degree that includes a certain amount of statistics, pick a maths and statistics or maths with stats degree. Or a combined degree. Now I saw, but just before I started, there was one of the questions which potentially has been answered by Paul, has on what sorts of combined degrees are there in maths, and these are increasingly important actually. Lots of people, not an overwhelming number, the majority of people who do maths at university do just pick maths, but an increasing number are doing maths and something else. And certainly we find at Lancaster the big subjects to combine maths with are finance. So sometimes that's called financial mathematics or maths with finance. Economics. Computer science has grown a lot in the last couple of years, I think, because computer science is itself increasingly popular. Philosophy. Maybe that surprises some of you, maybe that doesn't surprise quite others, but there's similar ways of thinking. If you like solving problems and dealing with the big questions, then philosophy can combine very well with mathematics. Physics, so at Lancaster we do a combined degree in theoretical physics and maths, and that's, again, I guess the similarities are fairly clear, particularly if you like mechanics, then a sort of a combined physics maths degree might be for you. And the last one I will mention has the confusing title Morse. They're big on that at Warwick. They also did it where I'm from, Lancaster, Southampton, Cardiff. That is maths operational research, which if you've ever done a module in decision maths or discrete maths, it's that sort of maths. Statistics and economics, and they go very well together, and they're interesting things to consider. So they're the main, I think, combined degrees. That's, I think, the main reason. There are wonderful career opportunities for maths, and I don't want to underestimate that. But to me, certainly when I was thinking of doing maths, the career opportunities were a bonus. It's good to know that after I've studied this, there will be things for me to do. But I think enthusiasm for the subject is the main thing. And I think the fact that it doesn't restrict your options as well, mathematics. So if you are very confident that you want to be a chartered accountant, then maybe a degree in accounting would work absolutely fantastically for you. But if you're unsure, then a degree in a broad subject like mathematics, you could still end up becoming a chartered accountant, and you do the study for that after you graduated with a first degree. So maths doesn't really cut off any pathways, and that's one of the reasons it's so popular. You can, in a way, keep your options open and decide, with the help of university's career service. Pretty much every university has got a very big career service with advice and so on in what you could do with your degree, and make the decision in second, third year of your degree when hopefully you're more mature and have a better idea of what you want to do with your life. Some of you may be watching this who haven't yet picked their A-levels, and I would encourage you to consider A-level further mathematics. Indeed, I think I would strongly encourage you to consider it. It's not essential, except at a few universities where it is. So do look at the prospectuses, but most universities will only generally ask for A-level maths, but pretty much everyone will encourage A-level further maths. And the main reason why I think is that A-level further maths is a much better showcase of the sorts of maths you do at university than single subject A-level maths. If you're into further maths at A-level, that's a pretty good indicator that you'll enjoy a degree in mathematics. And several of the topics in A-level further maths are just the sorts of things that are picked up in the first year of a degree. If you're not able to do that, do have a think about picking up AS further maths in year 13. So some of you might be in year 12 now or just finished, and you're thinking, oh, well, I didn't do A-level, I didn't do A-level further maths from the start. Well, if your college or school will let you do an AS in further maths, that's a great way of picking up some of the topics like complex numbers, matrices that are particularly big in the first year of a maths degree. Not essential, as I say, except in a few places, but a great way of meaning that the transition to university is a smooth one. It's always good for the move from school or college to university to be a smooth one. And I think doing a little bit of further maths is a good way to ensure that. What sorts of questions should you be looking at if you're looking around at different universities? Because most universities will have a similar, what I would call a core. You know, you are going to learn some what we call analysis, or hard calculus, as it basically is, algebra, which is actually matrices and symmetries, geometry, which is more closely related than you might imagine to algebra, and topology, which is the study of shapes to some extent. And pretty much all universities will have this sort of pure mathematical core wherever you go. But then there are differences and there are often options, and that they often reflect the particular strengths of the university. So I'll give Lancaster as an example. We have a lot of very good pure mathematicians at Lancaster. We've also, one of our big thing, if you like, if you ask people worldwide, what's Lancaster famous for in terms of its maths department, they'll say, oh, they've got a really big stats section, haven't they? And that's the case. So that's kind of our specialism. So those of you who are watching this who really like stats, I like to think that Lancaster will be on your list. But don't worry if you don't enjoy statistics, because you know it is possible to come here and almost entirely focus on pure maths. And other universities have similar specialisms. You have some which have a specialism in sort of the links between maths and engineering, which you can focus on, or just stay with the pure. Some really spend a lot of time on applied maths and mechanics. And again, you can really focus on that, or just do the pure, or like most people do, a mixture. So if you are interested in some of the applications of maths, then maybe looking around at the different universities and the different specialisms could be a thing for you. But if your main thing is pure, then most places are going to be fairly similar in the sorts of topics they cover. So you may want to look at other things like, is it a campus uni? Is it in a city? That's a big thing. How many students do they take? What sort of grades do they offer? What sort of structure do they do? How important are exams in their assessment thing? Those are the big things. But in terms of what you'll be studying, you know, everyone's going to learn about what a group is. You may not know what a group is, but you would a couple of years into a maths degree. And it's all about, if the pure is your thing, then it is about the other things like lifestyle, environment, and so on. Couple of, and I'll just conscious of time. I want to spend a bit more time. Just questions that you should ask. Accreditation. So this is external bodies that often give their stamp of approval to individual mathematics degrees. And there's kind of two I'll mention. The Institute of Maths and its Applications, which is a professional body for maths, they accredit maths degrees. So what happens is, say at Lancaster, our degrees are accredited. And what happens is we send off our programs to the IMA and they come back and say, yes, this is a good maths degree. It's got our stamp of approval. So that's worth looking at. And then there's a body called the Royal Statistical Society, which does a similar thing with statistics. Because most statistics is studied in conjunction with maths, what they will do is they'll look at a degree in maths, either and or with stats. And their stamp of approval says, yes, we think the amount of the stats options in this, we approve of these. So have a look at that. Is there a placement year version? So that's where you would spend usually your third year of 4 on a placement in industry. Lots of people like that. Not everyone does it. Is there a year abroad version? So this will be where you might spend 1 year of your degree somewhere else overseas. Most commonly the States, Canada, Australia, New Zealand, but Europe is increasingly popular. Is there an undergraduate master's version? So this is like the 4-year standard degree as opposed to a 3-year bachelor's, where you would exit not with, say, a BSc, but with a master's level qualification, sometimes called an M-Math, sometimes called an M-Sci, but a master's level. Worth thinking of whether the options are there, even if you're not sure. If the option's there, then normally at most places you can switch into these versions of the degree. And I'll also very briefly mention that the Scottish setup is generally very different to the setup in England, Wales and Northern Ireland. And I think, yeah, you've got 5 choices on the UCAS form. It's often worth putting a Scottish option there because some people really, really like the slightly different way they do things in Scotland. In particular, they have a more broad-based system. So you do not just maths essentially in your first 2 years, but you combine it with other things that take your fancy. And then you would narrow that down to a more focused final 2 years. So the standard length of a degree in Scotland is 4 years of what they call honours study there. Again, some people really love that ability to have a broad-based education. So it's worth looking at. And penultimate slide, what do you do with this? So this is a list of actual things Lancaster graduates have moved on to. Some of these you will have possibly been able to guess. Teaching is still a very, very important vocation for maths graduates. An actuary, that's really working in insurance. Risk analysis, that's working for a bank or insurance again. We have many people moving on to statistics and for bodies like the Met Office. And I guess because, as I've said, Lancaster has quite a specialism in statistics, you might not be surprised. We have some going off into the forces. So again, you get people, a lot of the armed forces appreciate mathematical background for officer recruitment. And we do have someone who went into the casino business, not because of their amazing style at the roulette wheel, but because if you're trying to spot people who might be playing the system, then having people who understand that system is a very good thing to do. I'll mention that also at the bottom. Probably one of the biggest public sector employers of mathematicians is the UK government, the civil service, and in particular GCHQ. I think I saw their logo on Paul's flyer earlier. So that's government communications headquarters. So that's the security, basically, listening in on communications to stop, to intercept potential terrorist threats and generally to keep the country safe. They're very keen on selecting mathematicians at both undergraduate and postgraduate level. It's an interesting vocation, very much. And obviously the links between mathematics and GCHQ is going all the way back to Bletchley Park and Alan Turing is a very particularly historically important one. So I'll round off there, happy to answer any questions. But essentially, if you're listening to this, we hope you love mathematics, and we hope you will think about picking mathematics as one of your options. And as I was saying at the start, there's still a lot of unsolved problems, and we hope that some of you will be the people who will solve them.